Okay, so we're going to cover 5.3 trigonometric functions of any angle. So here we have a right triangle. We have length x and y as the legs and r as the hypotenuse. And then we have this ray. It says, let this triangle be a right triangle with acute angle theta. Suppose that we orient the triangle from angle theta in standard position and label a point PXY on the terminal side of theta. Okay, so this would be the initial starting part of the angle, right? It's the bottom ray, and then the top ray is the terminal side. The length of the horizontal leg, we're gonna use the diagonal theorem to find R. And that's pretty much it. Okay, so now this is when we use our trig functions. So remember SOHCAHTOA. So you always look at the angle theta, and then in relation to theta, we're going to find the sine, cosine, tangent, and then of course you can get the inverses. So cosecant, secant, and cotangent, right? So here, just to practice, we have this angle, right? And then we look across from it, and that would be the opposite side. Then the side closest to the angle is the adjacent side, and then adjacent. And then of course we all know what the hypotenuse is, right? It's the diagonal side of the right triangle. Okay, so for sine of theta, we have opposite over hypotenuse, which in this case would be y over r. For cosine theta, we have adjacent over hypotenuse, so that would be x over r. And then of course tangent is opposite over adjacent, so that would be y over x. Okay, so in terms of their inverses, here if you wanted to get, I guess we could go here, if you want to get cotangent, we know that that's the reciprocal of tangent, so that would be x over y. Over here, secant is the reciprocal of cosine. And then over here, let's change this. Over here, cosecant would be the flip of sine, right? The reciprocal of sine. Okay, so you probably already know this, you probably already do this, but it's helpful to look at, and this you need to know yourself. So SOHCAHTOA, always go back to it, use the angle as reference, find the opposite adjacent hypotenuse side, and then you can solve for theta, depending on what you're asked for. Okay, so now we're ready to begin. All right, example number 1, it says evaluating trigonometric functions. Let P, a point, -2, -5, be a point on the terminal side of angle theta drawn in standard position. Find the values of the six trig functions of theta. Okay, so we're going to practice. So with these, you know, we're used to using the right triangle, but we're going to do this by drawing the point. So here we have -2, -5. All right, that's the point. So that's going to be the terminal side of angle theta in standard position. Okay, so then theta is going to be all of this distance, right? Go around. Okay, let's make sure we label this point x, y. Alrighty. It says here the distance between the point, which in this case is -2, -5, and the origin is, we're going to use the formula for r. So over here, using Pythagorean theorem, we know that you can square the legs, right? So if you have one leg with length x, another leg with length y, we square them, add them, and that would give us the radius squared, right? The hypotenuse squared. And then of course, how do we get the hypotenuse alone? square root both sides. So it'd be the square root of x squared plus y squared, right? They like to use r for hypotenuse, so that's fine. Okay, so now we're going to go ahead and we're going to find sine, cosine, tangent, etc. Okay, but first let's find r. So r is going to be, since this point is -2 comma -5, it's going to be -2 squared plus -5 squared. Right, and that gives us -2 squared is 4, -5 squared is 25, so it's the square root of 29. So this length r that is created using the point on the terminal side of the angle, meaning the last ray, right, the end of the angle created by it, drawn in center position. Okay, so now let's find our trig functions. Okay, so over here we have y over r, so it'd be -5 over the square root of 29. Okay, x over r, -2 over the square root of 29. And then tangent y over x would be -5 over -2, which is 5 over 2. Okay, remember that whenever you have a square root in the denominator, you don't want to leave it there, you want to rationalize it. So here you're going to multiply by the square root of 29 on top and bottom. Okay, square root of 29 times the square root of 29 would just be 29. And then here we have -5 times the square root of 29. For the most part, you don't have to really worry about simplifying it. You'll see that most of these numbers are imperfect squares, so this is good enough. Okay, same thing over here. Let's rationalize the denominator. So it'd be -2 square root of 29 all over 29. Okay, perfect. So this method, not a very common method, is to use the point given the standard position of theta and the terminal side, and then use the Pythagorean theorem essentially to get the length r. And then by there, basically we're using the same formulas. Okay, in the future, as we get to the next section, you're going to be able to just draw our right triangle. We're going to be able to just use the sides, which is the way that I prefer to do it. Okay, so over here, we know that to get cosecant is the reciprocal of sine theta, so it would be -29 over 5 square root of 29. You know, maybe we should just go back to this original. It would be r over y, which is the square root of 29 over -5. Okay, you can put the negative on the outside. So that means you don't have to rationalize anything, you could leave it like that. For secant of theta, it is the reciprocal or flip of cosine, so it would be r over x, which is the square root of 29 over -2. Put the negative on the outside. And then last but not least, cotangent would be x over y, so it'd be 2 over 5. And you can leave it like that, you don't have to turn it into a decimal or anything.